we have a bucket size of 3 and we need to hash the following values, and we will represent those values in a binary format to assist in the hashing process. We have converted all the values in the binary format. Then we will initial directory and insertion. So in the directory we will start with one bucket and the bucket 0 will initially be empty. Then we will insert values. So the 16 one will go in the 0 bucket and the state will be not overflow. Then the 22 one will go in the bucket 0 again with the state of no overflow. And when we put 26 and later 20, so during the 21 the bucket overflows and we need to split the bucket 0, and it will be splitted into two, bucket 0 and bucket 1. Bucket 0 will be having 16 and bucket 1 will be having 22 and 26, and so on. And at the last we get the final state of how many buckets we have and the values stored in each bucket. It's a summary. Now I will discuss the second question. Yep, here it is. So this is the question and the code. I have provided all the outputs and as a screenshot in the assignment. So yeah, I will explain this thing. The depth represents the local depth of the bucket. The bucket size is the maximum number of values the bucket can hold. The values store the actual data. Is full checks if bucket is full. Insert tries to insert a value into the bucket. If the bucket is full, it returns false. And the REPR provides a convenient way to print the contents of a bucket, including the depth and values. Now, the directory class. Here, the global depth controls how many bits of the hashed value are used to access a directory. For example, if global depth is 2, we use 2 bits to find the corresponding bucket, which gives us 4 possible bucket entries because it's like 2 raised to 2. Then buckets. This is the main structure that holds the references to the buckets. Initially, it creates 2 raised to the global depth buckets, the double directory. This method is called when the directory needs to grow. It increases the number of bits used in indexing and duplicates the existing directory to allow more buckets. Then the split bucket is used when it is full and redistributes its values. It creates a new bucket and increases the local depth of both the old and new buckets. The split mask is used to decide which values should stay in the old bucket and which should go into the new bucket. The directory is then updated to reflect the presence of new bucket. Then insert is used to handle inserting values into the directory. It calculates the index in directory using the lower bits of the values based on the current global depth. If the bucket at that index is full, it checks whether the local depth of the bucket equals the global depth or not. If so, the directory is double, and then the bucket is split and the value is reinserted after the split. Display. This function prints out the current state of directory on the bucket, showing the global depth and the content of each bucket. Then this is the main function for testing. Here we have the input mode, which allows us to input 3 different options. with the one is the manual input, then the file and the random values. The bucket size defines the size of each bucket. The directory initializes the directory with a global depth of 1. The directory dot insert values insert value into the directory, and displays the final state of the directory. So yeah, that's the whole code, and all the outputs I have provided in the as a screenshot in the assignment as well. Now this is a third question which asks for the external merge sort. So here we have imported the numpy for generating random number and heapq for implementing a priority queue used in the merging process. The page size specifies the maximum number of records that can be stored in each page. The buffer size defines how many pages can be loaded into memory at once for merging. The num pages indicates the total number of pages to be created. Now, this is the data generation. This line generates a dictionary called data, where each key corresponds to a page number, and each value is a list of 5 random integers created using NumPy. Now, write to disk. This function simulates writing data to disk by simply updating the data dictionary. It takes pages data and pages num as arguments and assigns the pages data to corresponding pages in the data dictionary. Now we start sorting the pages. This function sorts each page of data individually. It iterates through each page and sort the list of integers and update the page in the data dictionary. Then merge sort pages. This function handles the merging of sorted pages. Output is a list that will store the final merge result. The pages is the list. Load the first buffer size pages into memory, and the min heap initializes an empty min heap to keep track of the smallest element across the pages being merged. Now we push the first element of each page into a heap. Yes, that's the code. And then this is the merging process. The while loop continues until the minimum heap is empty, and the heapq.heap_pop retrieves and removes the smallest element from the heap. The smallest element is appended to the output list, and if there are more elements in the same page, the next element is pushed into the heap. This process keeps on going until all elements are merged. And here it's the final output, which we can see due to this line. And yeah, finally the code calls the sort pages function to sort all the pages, and then merge sorted pages to merge those sorted pages into one final sorted list. And here is the final output which we can see. Thank you.